So I'd rather not do the intro.
Great. All right. So let me do a quick intro. This is Joel Hawksley is speaking about view components in real worlds. Um, this is actually an interesting theme because I think you can go back and look at some of the videos he's done. Although I think the last one he did in last January he wasn't because he bagged on. Well, no, he didn't. He didn't do anything. Um, I'm not sure it got recorded, but this is Joel works for GitHub and has been a long time Boulder Ruby member. So please join me in welcoming Joel.
Cool. Thanks, guys. Since this is all full screen, I can't see Zoom anymore, but I can hear you, and I have chat on a device below me. Can someone say they can hear me?
We can hear you.
Hear you.
Sweet. So if you want to interrupt me, please interrupt me. If you have any questions, or put it in the chat, although I can't promise that I'm going to be able to look at the chat the whole time. Anyways, so my name's Joel. I work at GitHub. I wanted to say thanks for having me. Thanks to Rylan, Dan, and Marty for organizing this meetup. Marty, do you know what year it is? Is this like 14, something like that? 15? Maybe we lost Marty.
It's starting 15, yeah.
Oh my goodness. Well, yeah, I'm super excited to be part of this meetup. So today I'm going to share some lessons we've learned building view components at GitHub over the past year. I've been at GitHub for a couple years now. I'm an engineer on what we call the design systems team. Here's our team photo from Halloween this year. There's about a dozen of us on the team right now. We're responsible for the primary design system that's used throughout GitHub. You can think of this in very general terms as our version of Bootstrap. It's actually quite a lot of things. It provides the design patterns that we combine together to build UI. It has all these pieces. We have a CSS framework, we have React components, we have the view components I'm going to talk about today. We have our Figma, our whole Figma library. We have a set of octagons, and we have, I think most importantly, we have some interface guidelines that actually teach people how to use all of it. So my job on our team is to help the hundreds of people that use our design system to use it correctly in our monolith application. I help them build consistent, accessible, and resilient UI, and just generally make building UI an enjoyable experience in Rails. And we're doing this in one of the biggest, most highly trafficked Rails applications in the world. And every time I give a talk here, people ask me so many questions about GitHub stats and like what exactly our scale looks like. So I tried to come up with like every single stat you guys might possibly ask me about and just start the talk with that. So the GitHub app is over 13 years old. It was first developed in October 2007, and I think GitHub launched in spring 2008. Our app receives tens of thousands of requests per second. And our architecture is what we call a citadel. We have a main Rails monolith and then about 24 services that kind of orbit it. A lot of them are written in Go. They're extractions from the monolith. One I was talking about earlier during social hour was our webhook delivery service, and that's kind of a good example of a specialized extraction we've done. But by and large, GitHub is a Rails monolith, and it's really big, and it's growing quickly. So to give you an idea, we have 580 models, and we've added 144 of those in the past year. We have over 4,500 views, and we've added 700 in the past year. We have over almost 800 controllers. We've added over 200 of those in the past year. And what really matters to our team is that we have over 2,000 screens in the application, at least if you look at the routes file. And all of those views need to stay current, even if they're out of the critical path. Another problem with this is that we have a lot of legacy one-off designs that are difficult to maintain. So at this point, I think actually if you were to load GitHub today, you'd get over 450 kilobytes of custom CSS when you load any page on the site. And that's because we have just numerous copy-pasted blocks that get added for every new feature, and they're all kind of appending to one style sheet at the moment. So looking at all those stats, you can kind of imagine that this scale could make for some interesting problems. And, like an overarching lesson from the scale has been that things that might be a small annoyance in smaller applications can become serious roadblocks at our scale. So when you have a body of work like this with these thousands and thousands of examples, it's really possible to zoom out and see some patterns emerge. So one example of how I've worked to improve the developer experience here is what we're calling template annotations. And this all started with seeing developers having problems figuring out which template rendered a specific line of HTML in our application. So for example, if you're looking at a pull request page and you see this draft PR badge, how do you figure out what template rendered that badge so you can go in and modify it? So you might look at the source. You could try searching by the class names that are on that element. But a lot of apps are built with these, what you call functional CSS frameworks these days, which means you don't have like unique class names or identifiers on a lot of your elements in the DOM. So if you search for, say, flex shrink 0, you might get, in our application, thousands of results. So it's really difficult to trace what's rendering what with that technique. So in thinking about this problem, someone had asked if it might be possible to add HTML comments to our templates when they're rendered into the DOM, showing the beginning and end of each template's output with the path to the template file. And this is exactly how we did it. For my talk today, in a change from previous years, I'm trying to swing in the other direction and just show actual code from our application versus example code. So if you guys have any specific questions about this code or want me to slow down in my explanations, please let me know. I know that I've looked at this code a million times, so I know what it does. But I'm going to try and explain it well. So we wrote a custom ERB compiler that added the template path to the output of a template. So we start by defining a handler object with a call method that receives a template object. And this is a standard interface for ActionView template handlers. Then in the first line, we call the super method of the handler we're inheriting from, and we grab its output and we do a small transformation on the result. And then we take that output and we inject before and after that output HTML comments. So we look at that template object and we extract the short identifier. In Rails, this is basically the path to the template. And for now, we do this only in development. We basically register this custom ERB handler, which is a modification of the built-in Rails ERB handler. So when we go to render the page, you can see now that we have comments before and after this element. In this case, it's actually rendered by a ViewComponent. And now we have a way to quickly figure out which template rendered a part of a page. Is that a good pace for y'all on looking at code?
Yes.
Cool. So after seeing the benefits of having this patch in our application, we put it in Rails. So this is actually part of Rails 6.1. You can turn it on with the configuration variable config action view annotate template file names. And new Rails applications will have this enabled by default in local development. I would love to see us turn it on in production, but some people at work think otherwise right now. So another issue that's come up.
Joel, sorry, real quick.
Yeah.
If I jump in with questions?
Yeah, sure. This is anytime you see this slide, it's a great time for questions.
Question is, why are people hesitant to turn on at work? Is it a security issue or a performance issue or something else?
I think the general implication is that it might reveal something material about our application. I happen to disagree. I think it'd actually be really cool if we showed people like how we structure our pages. Like it's actually pretty incredible how many templates go into rendering, say, like a pull request page. It's probably maybe like 50 or 100, depending on what's on your timeline. And I think people would. It's kind of like it would be kind of like source maps for, for JavaScript. So another issue that's come up, and I've seen this at a lot of companies besides at GitHub, is that it's often really hard to get our applications into the right state in our local development environment. And as you can imagine, I'm working on a design-focused team. This is a really common need for us, especially as, say a designer wants to go in and test some visual changes in our app. Obviously, you can do this with seeds, but as you can imagine, with GitHub's architecture, we have this monolith with tons of services. Some of them are a little bit harder to run in local development, but yet somehow we manage to do it in our tests. You know, we write stubs, or we have these fake services that that help our tests assert that they're integrating with these other services properly. And while this is great for, say, integration tests or unit tests, it's really not a lot of help when you're trying to make visual changes in your local development environment. So the other problem is that we don't have browser-based tests, which means we can't use them for verifying our visual changes. And this is mainly due to how much time it would take in our test suite. You could imagine if we had system tests for 2,000 pages, how much time that would add. Our test suite as it stands, this is another stat y'all always ask me about, is like, I know it's in the it's between 15 and 20 hours if it's not parallelized, if you were to just run it straight through, depending on the machine. So thinking about this, I realized that we do write a ton of controller tests, which have all the setup we need to get our environment into the right state, because we need that to do our controller assertions. So I had an idea. What if we could temporarily convert our controller tests into system tests? And that way we could reuse all of the existing setup code from our controller tests to preview the application in a specific state and use that to make visual changes. So that's exactly what we did. So as a quick refresher, here's what a controller test looks like. Starts with a git call to a URL and then makes a basic assertion. Obviously, controller tests also look very different than this, but this is a simple one. So how could we convert this test into a system test? So we can start by writing a module, and we'll call it system test conversion. And that when this module is included, it registers some configuration for the system test case class. And then in this case, we really just needed to define two methods, and they're quite short. One is to redefine get to instead load the visit method from system tests, and then pause with the debugger. And then we need to basically no-op that assert response method. So from there, we can conditionally include that module if run in browser is appended to a command to run a test. And here's what it looks like in practice. In this case, we have a login step. I kind of left that out. But you can see we've actually booted our application and are able to preview visual changes in a browser just based on a controller test. So unlike template annotations, this change has not made it into Rails. I am still not sure if it's a great idea outside of GitHub, but it's served us really well. And perhaps there's something bigger that we can learn here, though, which is that our seeds and our test setup code have a lot of overlap. And I think that there's a lot of ways that we could potentially bridge the gap between these conceptual domains. Any questions? Cool. So yet another little problem we worked on was, let's see if how can I explain this? So when you're modifying a template in Rails, it can sometimes be difficult to know the consequences of those edits that you're making. You know, templates can be reused, they can be rendered multiple places. Some of those places might be difficult to build on. The previous thing I just covered, it might be difficult to reproduce the state necessary to preview some of those pages. So not knowing where a template is used is risky, and we have a ton of template reuse in our code base. My colleague, John Hawthorne, actually did some static analysis and built a diagram of how our templates reference each other, and it's pretty crazy. So as you can see, navigating this render stack could be a little tricky. So we turned to static analysis to do it. So we built a tool called Viewfinder, and we're going to go through an actual use of it. So say I'm editing the wiki show page. This is a very standard Rails view for a wiki resource. You can call bin viewfinder and pass in the path to the template. And I'm going to share some code here. This is kind of like a simplified version of what we do here. But we extract the template, string literal. In this case, it's literally wiki/show. And then we just do literally a find and replace in the code base. This is the same thing that would happen if you went into VS Code and did a global find and just typed in wiki/show. And then what we do is for each of those search results, we load the file into the parser gem, which returns what's called an abstract syntax tree of the file. So for example, if we do that wiki/show search, one of the results is for a controller. And here is part of the very large syntax tree that we get back. So this data structure represents how Ruby interprets the code that we write. And as an aside, this is the data structure that Rubocop uses under the hood for a lot of its linters. And you can see at the bottom of this tree that we have our render call to wiki/show. And just for as a quick aside, if you want to see the equivalent code that this tree maps to, here's the same code. So you can see we have this as a very typical like respond to do format.html, render a specific string literal, and then the AST representation of it below. So the cool thing about syntax trees is that we can query them, we can traverse them. They're tree structures, and which means we can start to have a programmatic interface for our Ruby. So not going into, again, too much detail, but we're able to find the calls to render by looking at the type of the syntax node and then looking at the method name. And then we do this basically to say like, okay, if I search for wiki/show, let's make sure that this is actually a render call to wiki/show and not that string somehow matching somewhere else in the template. So we continue until we reach a controller action. And then we go back to the syntax tree and we look up the tree until we find the definition of the controller method. So in this case, we've looked up the tree and we've seen that this is inside the show method, which means in this case, it's the show method on the WikiController. From there, we can look at the routes inside Rails that render that controller action, and we can return that result to the console. So now we have this diagnostic output that says, given this template, we can see that this template was rendered in actually 2 controller actions in our application. It's rendered when you load any page in a wiki, and it's also loaded for the index action as well. So by itself, this tool was really useful. We could see all the routes that rendered a specific template. But then we realized we could use these routes to identify which controller tests rendered each template.
Actually, Joel, can I ask you a question real quick before?
Yeah.
With the AST, is that,
sure.
I haven't done a lot with ASTs. Is that smart enough so that if someone was like, had a variable called, I don't know, something, and they basically like concatenated 2 variables, one that had WI and the other had KI. Would it notice that?
No, not at all. And I'll mention this towards the end of this section, but this whole tool depends on us having a linter that enforces that you pass a string that is a valid path to the render call. And that's something we do actually for other reasons in the code base, not just for this. So to get back to what I was talking about, so we use these routes to identify which controller tests render our template. And you can imagine where this is going. We just talked about using controller tests to preview our visual changes. We did this through a similar process to what got us to this point, though. We started by doing a global find for all of the Git calls in our integration test suite. So this is every test that literally just says like Git /Joel Hawksley /demo/wiki. You can imagine this literally as like a github.com route in front of that. So what we do is we parse this and we extract the argument from the call and we pass it into the Rails code path that takes a request and returns a route. This is literally the exact piece of Rails code that when you make a request into an app, it looks up the controller to send your request to. So this, when you pass it in, it returns this route data structure, which has the controller, the action name, and then the parameters that have been extracted. So we do this over and over for every single controller test in our code base. And we build up a hash that looks something like this. We say, we have the controller action as the key, and then the matching tests as an array of values. So once we have this lookup hash, we can then include which tests render the view in our output from our viewfinder tool. And what's great is that we can then use those test cases with the system test controller, system test conversion tool I just talked about, to visually verify the changes to our template in a browser. So what this means is that, like, given a template, I can now enter into this tool and it will tell me what controller test to run to preview the changes. And this has shaved hours off of sometimes people's just like one person's week of work working in templates in our code base. So there are some downsides with this. It only works with explicit render calls where a template name is passed to render. And like I was mentioning to Dan earlier, we enforce this with a linter. This also doesn't account for conditionals. Like when you're doing AST, you don't know whether you're going to be in like an if or an else block. So this is what we call an optimistic approach. It's going to tell you all of the possible routes that might render your template. But it has proved really useful for us, but it is definitely not ready for prime time because most people don't use the linter that we use with our render calls. Any questions about that?
You don't run a Github action with it, force them to?
The problem is that right now it's actually pretty slow. We cache, like for example, that where we like parse every single test and like map it to controller actions is quite slow, but we end up caching it locally, so you don't have to do it too much. Okay, so the next thing I want to talk about is maybe...
I have a question.
Sure. Yeah.
How long was something like this, process for a building? Like, what was the process for building something like this? Lengthwise, like time.
Oh, time-wise? I think engineering work, I would tell you it was probably about 2 weeks of my time. Like, in terms of like... It's hard to say that because it was obviously built over a longer period of time, but it was probably 10 engineering days, like, which for me is about like, I usually do like about half my day is actually engineering. So like 40 hours of actual coding time.
Right.
We also, my now former colleague, Katrina Owen, who's really big in the Ruby community. She is big into AST work. A lot of what she did here when she worked here was in AST. So she was a huge help in figuring all that out. It probably would have taken me 100 hours without her.
Maybe this is a newbie question. What does AST stand for?
Abstract Syntax Tree. And that is a universal term.
Cool.
So you can, I don't know enough about the internals of programming languages, but most languages are interpreted into an AST as some step of the process of the code actually being run. So we're basically just looking under the hood and saying like, oh, okay, Ruby interpreter, let me see the data structure you see when you see this Ruby code. And that allows us to learn things and perform operations on our Ruby code that you otherwise might not be able to. This can be really helpful for any language. You could imagine how it'd be actually really helpful to have an AST for HTML if you wanted to lint your HTML. This is, in fact, a lot of linters work on top of ASTs for that reason.
Cool. Thank you for explaining that.
Yeah, that was actually the main goal of sharing that example, was just to show like how you could use an AST to solve a technical challenge.
For sure.
Yeah.
Cool.
So I think the biggest challenge, though, that I've been looking at has been what I've kind of referred to as a missing abstraction. And it's a piece of our view layer that has increasingly, as we scale bigger and bigger and bigger, like as we're adding 700 views in a year, there's like something I think that's very clearly missing. And the way I like to look at this problem is through the rule of three. So a common rule of abstraction is the rule of three, which Martin Fowler describes as: the first time you do something, you just do it. The second time you do something similar, you wince at the duplication, but you do the duplicate thing anyway. The third time you do something similar, you refactor. So I think that this is something a lot of programmers have in common in their approach, is that they do something and they do it again. And then when they do it a third time, they start to think about, what could I do that would, clean up this, provide an abstraction, simplify this, make it so I don't have to write the same thing over and over and over again. And we do this for a ton of reasons. You could think about consistency. You could think about maintenance. Like if you just copy and paste your code over and over again, it's going to be really hard to update those copies. Maybe they'll drift and be different. You guys could probably think of a million reasons why the rule of three is a good thing to follow. And I think this is especially true for review code, but yet that standard seems to be ignored when we're writing templates. In general, our templates are built by copying and pasting chunks of ERB or Slim or whatever we're writing in from existing templates. And this makes it incredibly difficult to make sweeping changes in our view code. And the reason this is a concern to me is that, I'm on the design systems team. Our job is to make sure our designs are used consistently throughout this giant code base. And if people are just copying and pasting code and not having some sort of higher level abstraction around it, it really limits how effective we can be. You can think of this as especially being amplified by the fact that our code has been around for over a decade. There's a lot of code that's written by people that are no longer working here, and it's just a really big problem for us. And just maybe more generally, our Rails Vue code doesn't live up to the standards we hold our Ruby code to. I won't go into a ton of detail of that, but like if you were to think about how we write templates, if it was Ruby, we get away with a lot of things in our templates that we would never even consider doing in our Ruby code. Another thing is that our views are generally poorly tested relative to other code in our code bases. So they're tested with integration or system tests, which are slow, which means we write fewer of them, or in GitHub's case, we don't write any system tests. So in 2019, I had a crazy idea, and that idea was to use Ruby objects to render views inspired by ideas from React. And I actually prototyped this idea as my first talk here at Boulder Ruby. We now call this ViewComponent, and it's a framework for building reusable, testable, and encapsulated view components in Rails. And a view component is pretty simple. It's a Ruby file and a template. So on the left, we have our test component. It is a subclass of ViewComponent base. It takes an initializer with a title argument. It assigns that title argument to an instance variable. And then in our template, we use that instance variable for the title, and then we render the content that is passed to that component inside the span. And to render this component, we instantiate the object and we pass it to render, and then pass a block into the component. That block is captured by the ViewComponent framework and assigned to that content accessor that you saw here in our template on the right. And then when it is rendered, it returns this HTML. You can see that the title we passed in has been assigned to the title attribute, and the block we passed in has been assigned to that content accessor and rendered inside the span. Does that make sense?
A bunch of us are nodding.
Cool. I really wish that when I was full screen that I could I almost should just pull open the grid view on my iPad or something. Anyways, so to test our component, we can write a unit test that renders the component and then asserts against the output using your standard capybara matchers. And these tests are really, really fast. To give you an idea, in our code base, they're on average about 100 times faster than the equivalent controller test. So having the ability to unit test view code has been a huge game changer, because before we used to treat our DOM tests as like a luxury good. When you have a system test, you really, you guys have probably seen this in your test suites where you'll have one system test and it does a ton of things because it's so expensive that you want to smash all of your assertions into one test. Well, with unit tests, they're basically free. You could write 100 of these and they might take 1 second to run. They're very quick. So in 2020, last year, I joined the design systems team to work on this project full time. And since then, we've been rapidly adopting the pattern in github.com. So to go back to our stats from earlier, I did leave one out, and it's that while the GitHub application grew on average by about 25% in the past year, our Vue components grew by over 15 times. We've added almost 375 components. Actually, at this point, we've added more, and we've learned a ton in the process. So one of the goals of the design systems team is to help our developers build consistent user interfaces, and Vue components have been really a key part in accomplishing this goal. So for example, last summer, my colleague Christian built a Vue component for the counters we use throughout the app, and you can see them here on the repository navigation. We rendered these counters over 100 different places in our application. And here's a diff from one of his pull requests, and it shows how we mixed and matched the formatting of the values we were displaying within the counter. If you look at the lines he's removing, in one case we use this number with delimiter helper, and in one case we don't. And this is on a page that's trying to display basically the same information, but it's doing it in two different ways, which meant that in certain cases when there was a large number of commits on this page, it actually was formatted differently, and it made people think that they were looking at different values somehow. This is an edge case we never expect a developer to test, even in production. And it's really just something we don't want people to have to think about. So what we did is we instead wrote a component that contained all of the logic we wanted to have around counting, rounding and limits and formatting and everything. And now the component just takes the raw integer and handles the formatting the value in a consistent way. Another one of the lessons we've learned from building our view components is that they enable us to help developers use our design system correctly. So one example of this is our subhead component. This is used 450 times in the application. And this is what it looks like in the correct way to build it with HTML. So you can see we have like a wrapping subhead class, and then we have two elements inside of it, a subhead heading and a subhead description. So in practice, we often ended up in cases where people were just using like the subhead heading or subhead description classes just like completely by themselves, which was out of line with our design guidelines. They are only to be used this way. So in the view component implementation, we instead accept block arguments for the heading and description, and we use this using a slot, what's called our slots API that I'll talk about a little later. So what this does is it allows us to help people use the design pattern correctly. They're not able to use just the subhead heading by itself. They have to use the whole component in the correct way. Oh shoot, that just jumped way far ahead. So another benefit we've seen from view components has been encouraging developers to write performant code. And one of the most common performance issues I've seen in view code in general is unintentionally querying the database. And here's an example actually from just a couple weeks ago. As you can imagine, we have a lot of permission checks in our views, because when you're looking at a resource, you might be able to see certain sections of the page if you're the owner of that resource, or if you have certain access to a repo. Unfortunately, these checks trigger queries if they're not batched properly. So to help developers understand how their view code might interact with the database, we redefined the render inline helper that view component provides to take an additional argument, which is the number of allowed queries. And most critically, we defaulted it to 0. So we take this and then we render the component, and we, using the Rails MySQL instrumentation, fail the test if the actual number of queries doesn't match what was expected. And this helper has been really educational, especially as people convert their code, maybe say an existing partial or something, to be a view component. It's really helped us understand the side effects of our code, and it's prevented the introduction of a couple N+1 queries. So in one recent case, this is just from late December, on the checks page, we found out that we had an N+1, and this tool, by converting our view code to be a component, we found 100 milliseconds of unnecessary execution time. So the checks page, thanks to being converted to a view component, if you're looking at it today, it's 100 milliseconds faster than it was in early December. So another advantage we've seen with view components is how they can help manage complexity. And one really good example of this is in our mailers. So I'm guessing, gosh, I wish I could see all the grid of you right now. Has anyone else had to write HTML mailers lately? It's insane. Like, it requires writing HTML like it's 1995. I don't know about you guys, but I was not of the ability to write HTML at that point, so I don't have a lot of experience with 1995 level HTML. And it's really fraught with edge cases. So most of our mailers are written with really, really heavy-handed inline HTML. And we have some tooling that makes this somewhat less painful, but it's really hard to maintain, let alone change without breaking something. And you can imagine when our designers said they wanted to use columns in our emails, how scared we all were to like deliver a solution that wasn't going to just be a total mess. So my colleague Mike thought it might be a good idea to build some view components to abstract away all of the tables in inline CSS. So to do this, he built some mailer-specific components for rows and columns, which we use together. So we start with our row component, and we pass in multiple columns. And what this does is it gives developers a really reliable way to build column layouts and mailers. And this is what I would call, I mean, this is a famous term DHH uses, but it's conceptual compression. And what this really has done is it's simplifying the process for building mailers, where we've practically removed the conceptual overhead necessary to build one correctly. So instead of worrying about whether you've written your inline styles in a way that works correctly in the numerous different mail clients we try to support, you can just piece together these two view components and move on with your life. So just like Active Record simplified our use of SQL, and controllers make it easy to write code to respond to requests, we use ViewComponents to make building UI correctly the default, not the exception. So another way ViewComponents can help simplify building UI is what we are calling slots. If you saw my talk last year, this is an evolution of what we previously called content areas. So slots are a way to pass multiple blocks of content to a single component. If we just pause for a second, are people here generally familiar with how, like, when you render a partial, you can pass in a block and then you can call yield inside the partial to render that block? Could I get like a thumbs up or something? Yeah. So
Yes.
you can think of this the slots solution problem space as like an extension of that functionality. So for example, take the box component from Primer. This is what the HTML looks like. We have, a header, a body, we have a couple rows that are in an unordered list, and then we have a footer. So let's try and write this as a view component. So we'll start with a component that renders our example code. This is a little bit too much code for this slide, I'm sorry, but the box component really doesn't, the actual Ruby file doesn't have much going on. I've just pasted that HTML you just saw into the template, and then we render it by just instantiating it. Skipping a few steps, we might end up with a couple of components for our header, body, row, and footer. This is the traditional approach that you might see done in React. But this puts a ton of burden on the developer. Just look at all these components. How could you ever remember to, like, oh, I got to use the header, and then I got to use the body, and then I got to use the row, and oh, of course the header is first, but like, how can we make sure it's always first? How can we make sure the footer's last? And this architecture does not prevent misuse of the design system, and this is where slots come in. So if we go back to that component, we can declare slots for each of these sections of the component. We can say that this component renders one header, renders one body, renders many rows because it's a list of them, and renders one footer. So in the template that renders the component, we can then refactor it to use slots instead of separate components. And this is what the syntax looks like. So we now have these methods that take a block. So if you call a component.header, you can pass in a block that will be for the header, and et cetera, et cetera. And for the row, you can actually call component.row multiple times, and we can provide multiple rows. So in the components template, we can then render the header and body, and then we can render the rows, and these rows, since we said renders many, are exposed as an array, which means that we can see whether there are any, and then if there are, we can build an unordered list that iterates over those rows and renders each of them. And we do all of that with the footer inside our wrapping div. So what we've ended up here is a codification of our design system that helps developers use it properly. And I think that this is, and from what we've seen, this drastically reduces the misuse of something as complex as this box component.
And Joel, you could, this is an order of the way that it's rendered, but it doesn't have to be, right? You could have header at the bottom, footer at the top. It may not be a good idea, but you could, right?
Yeah, actually that would make this example stronger if I didn't have them in the right order. Yeah, there's a lot of things you can do. You can also, like, you could imagine here, for example, that, like, say you had a collection of active record objects, you could actually iterate over them, and then for each object call component.row, and that would generate a row for each of those objects. So there's a lot of flexibility you can do here. So another thing we've experimented with is Storybook. Those here who have worked with React might be familiar with this tool. Storybook is an open source tool for developing component-based UI elements in isolation. And it's very popular. I think the repo has like 60,000 stars or something like that. And a member, just like someone in the community, his name's John Palmer, built support for ViewComponents in Storybook. So here's an example of what it's like to use Storybook with our Flash component. So you can see here previewing a change to the icon and then a change to the variant. So this is actually rendering our Rails component under the hood, and we have these now for all of our components. it gives us a development environment for building components outside of our Rails application. And in this case, it's for our Primer ViewComponents library, which we have recently open sourced over the summer. So this now has 24 components. We use it in a couple of Rails applications internally, as well as github.com. So if you want to see actual component code we're using in our app, you can check this one out. And we're actually not the only people open sourcing our components. The UK government, their Department for Education has released a ViewComponent library, and they have about a dozen ViewComponents. This is for the Gov UK design system. Any questions?
I might have a slightly brief question. Also coming from a newer perspective, can you talk about the decision to switch over to these components, and I guess like how long does that decision process take, and the kind of input? Because it seems like once you make that pivot to this, it can be an involved process.
Sure. I think that one of the things that really motivated this work was realizing that we were at a design level avoiding certain changes we really needed to make to GitHub's UI. Because of the technical debt we had. So the overall goal of this project is to reduce that custom CSS burden, ideally to 0, fingers crossed, such that we can more quickly iterate on our UI. I didn't mention this earlier, but my team is actually the team that built dark mode, probably like in my opinion, the most awesome GitHub ship ever. But that was a fairly difficult process for us because of a lot of the CSS technical debt we have. So doing that project and some other visual refreshes we did ahead of that really opened our eyes to how much of a tax we were paying because of our CSS technical debt. And that's great.
Actually,
go ahead.
I just want to build on that. Yeah, that's interesting because how many devs are at GitHub? Like 1,000 or so?
I'd say that in rough scale. Yeah, that's about right. Yeah.
So did you have to like get buy-in for a lot of this, or is it more like focused to your team, or how did that work? I mean, it's a whole different talk, but
I mean, GitHub is an interesting company in that we're very even now, like, how do I explain this quickly? GitHub started as a meritocracy. A meritocracy is where there are no managers and everyone does what they want, and that worked for 8 years, which is nuts. And while we have managers, we have product managers now. Those are two things we did not have up until, oh gosh, basically like 5 years ago. There is still this culture of demos, not memos, is the way people put it, which is if you have an idea, write some code, open a PR, see what people think. And this project started with that. Like when I wrote the original Boulder Ruby talk on this for the January 2019, it was of that prototype that I was proposing to the company. Like I think actually we landed it in GitHub like shortly after I gave the talk. We actually started using it in production. And that's kind of the level of preparation you need to have. And then from there, it's kind of been a gradual process. It's been like, okay, we see a benefit from this pattern, let's refine it, and then let's try it at another place. Find a new benefit, try it in another place. And that's been slowly growing over the last couple of years. But my next section is basically all about that. So how about we do that?
Well, Joel, while you're here a sec, what I think I heard you, or what I think's implied in what you were just saying, is that a barrier to getting the legacy CSS changed was partly that you had inconsistency in the DOM that was being emitted with all these custom templates.
Exactly.
And
so
getting view components gets you normalization in the DOM that gives you the lever you need to be able to go after the CSS.
Precisely. So we're attacking the problem from two directions. One is obviously just like trying to thin out the custom CSS, but then the other piece is really rewriting views to use these components such that they don't use custom CSS.
So hats off to you. It's a genuinely hard problem to refactor CSS. Like that's one of the things that sucks about CSS. And
I'm hoping that my talk next year is how we killed 450 kilobytes in custom CSS.
Yeah.
That's actually literally, I just spent a couple hours today meeting with a group of 10 people I'll be working with to do just that this year. So that'll be an interesting year. Anyways, so this whole talk is actually based on 2 questions that people asked in the Boulder Ruby group. One was, when do you use components and when do you not use them? I would hope that we kind of answered that with the previous section, which was just showing all the cool ways we've used them. The second question was kind of what y'all were just getting at there, which is like, what's the organizational component to this? Like what does this look like, to do all the like squishier things? So there's kind of 2 contexts when it comes to rolling out something like this. There's the technical context, which is writing new components, refactoring old views and the like. And there's also like the organizational, how do we ensure components are used correctly? How do we make the case for this work with, non-engineering people in the company, because it does take time and, time out of people's schedules. So let's start with the technical. How do we create view components these days? The first one is by refactoring existing view code into components. So before view components, we used a presenter-like pattern we called view models, which are Ruby objects we instantiated and then passed into views. So here's an example view model. The test, basically this is drastically simplified, but you can imagine it's an object with a status method. It looks at a repository accessor and says, if it's locked, show this string, otherwise show this other string. We test this view model with a very typical plain old Ruby object unit test. It instantiates the view object and then asserts against its output. So that's a view model. We pass this into a template and access values. So we might call view.status in our template. So let's rewrite it as a component. So here's what that looks like. We literally just changed the base class on the model. We'll ignore the template for now. It's not super relevant for this example. For the test, not a lot changes either. We use render inline. We pass that instance in, and then we assert that the text says enabled. And that's the thing that's fundamentally different about view components in my book, which is that we're working with the actual output versus this like intermediate Ruby object that then gets passed into a view. And what that means is that we're asserting against what's actually presented to a user. And this is something we could previously only do with our system and integration tests. And it's one of the main reasons that we're refactoring our view models to be view components. Is to give us that confidence that our view code is working correctly from the perspective of our customers. You can imagine this being especially important if we're refactoring, say, a really old view model written by someone who no longer works at the company and might have been on a team that no longer exists. So we also write view components from scratch, and we generally, we consider some of the reasons I mentioned earlier. Is there a need for strong consistency? Like we have 100 counters. That's probably a good case for a view component. Are there performance concerns? Are there, for one reason or another, certain things we want to make sure are really optimized from the database perspective? Is the view complex with a lot of different states? You can imagine a view with a lot of branching logic could benefit from being a component because we could write a unit test for all of the permutations. But honestly, if it doesn't meet those criteria, we still stick to building traditional Rails views. But I think the more interesting part is the organizational side of things. So communication I think it goes without saying, is incredibly important with something like this. And one of the ways we communicate about view components is via documentation. So I think Rylan actually just passed the link around in the chat to the view components site. But that site for all of view components is actually generated from code comments. And that's what I'm going to show here. So for that library, we use Yard, which is based on RDoc. And here's what that looks like. So at the top of our component class, we write a comment that describes the function of the component. We also provide some ERB examples of how to use the component. And then we provide what you are probably more familiar with in RDoc, which is these annotations of each of the parameters. And this allows us to write our documentation alongside our code, which means it's often up to date. You can also lint Yard documentation to ensure that, say that like your param declarations match the initialized signature. But then the fun really begins. So we can use these docs to build our site, like I just mentioned. So we have a rake file, and the first thing it does is it runs the yard rake task, which parses the project for those yard annotations. Then we take that, so yard actually parses those annotations into a .yard doc folder. We then load that folder into the yard registry store, which is completely undocumented, and it took a lot of, I actually just had to read the yard source to know that this even existed. But from there, we can take that object and you just pass in a class name to it, and it returns a docs object. So let's look at the docs object. So I think I actually call it documentation in this example now. But the first thing you can look at, there's a base doc string method, and that has that description that we wrote about the class. It also has data on every single method in the class. So we can filter, we can just run a find on that list of methods, and there's a constructor accessor that basically says, hey, this method's the initializer, and that gives us our initialize method. So if we look at that methods instance, we can look at its tags attribute and look at the tag names. And that, in this case, shows that the two parameters are size and system arguments. We can also see that we have those examples we wrote, and this is just the ERB that was in the comment. What's really cool though is that we can then take that ERB and we can instantiate an instance of application controller, look at its view context, and then render that ERB as an inline template. And that will actually give us the rendered output of the component. So from there, we have what we need to build our documentation page. And we use that data to build a markdown file. So we take that name of the class, clean it up a little bit and put that in as the title. You inject that description, and then we take that inline HTML and then the original ERB code. And again, this is a little simplified, but this is the docs page that's generated from that. And this standardized approach keeps our documentation really consistent. And I think my favorite part of this is that this documentation is now consumable both via the component code and the codes and the code comments, because people tend to prefer one or the other, and I don't want to play favorites. Another way we communicate with other developers at a company this size is with linters. So I've mentioned this on numerous occasions, but like GitHub uses an incredible amount of linters. It's like borderline hilarious in like the best way possible because they're super helpful and you just receive a lot of guidance from them. So for example, we have a bot that automatically reviews pull requests and looks for cases where we prefer people migrate to using view components. So for example, we have this old Octocon helper method. It doesn't have as many features as the component. So you can see that, we have this bot that goes in and says, hey, it looks like you're using this old thing. Could you consider trying the new one and let us know what you think? And that link is actually back to that auto-generated documentation site. So this saves us from having to make these suggestions manually in code review. And while I can't share like the exact internal statistics, it's basically done a lot of the work our team would usually do manually in converting these, because people are opening PRs, getting this feedback, and they're like, oh, that's like a one-line change. I'll just add it to my PR. And we've seen our use of the Octocon component just like steadily grow over time without any of our input. Another way we use linters is with custom rubocops. This is something that I've never seen done anywhere else, but you can actually just write your own rubocops and use them in your code base based on that abstract syntax tree we looked at earlier. So this is one of the rubocops that we've written, and this encourages people to use view components instead of view models. So this looks at the abstract syntax tree, and it specifically just looks at class nodes. So we look and see if the class is a view model. This just basically hacks apart the class declaration and sees if it has a view model in it. And if it does, it adds a fence with a really helpful message that I've kind of shortened here. It actually also links to some documentation. And, at our scale, if we want to do something really consistently, like move from, say, one architecture to another, like from view models to view components, really the only answer is tooling and metrics that guide people towards the right solution. So another way we communicate is basically with a blog. So this is a blog, it's not really a blog, but it's what we call an initiative tracking issue. And I write weekly updates for what we're doing in view component land. And we usually share, a handful of highlights, maybe some code that's been improved from using the pattern. And this provides, my manager, my manager's manager, people throughout the company, regular case studies showing how this work is like incrementally but like meaningfully improving our code base. And this is, I've been told, one of the key reasons why we have continued to get funding for this project really 2 years in to working on it. But, you know, at some point, like, all these things are helpful, but like there's really no substitute for putting in the time. So last year over the summer, as part of like a larger technical debt effort at the company, we put together a team of about a half dozen engineers, and we just spent 2 months building new components for the system and rolling out existing ones. And this is a graph of how many usages we had of components in our application over time. So it's really stable right up until August, where we see the slope really starts to change. In the 2 months the team worked on this, which was the results would be for August 1st and September 1st, we quadrupled the number of places we used components in our code base. But what was really interesting is we kept looking at these stats. Even after the team disbanded, the gains kept going up. And it was because people were copying and pasting. Because once we had gotten to a critical mass of using ViewComponents, we had enough examples for engineers to reuse as they built new user interfaces. So how do we ensure they're copying and pasting the correct code? I mean, whenever we're doing this big migration, a big risk is that someone will see a bad example and they'll reuse that one and not the good example. And we manage that with more linters. So for example, we talked about the counter component earlier. If you go and use the non-component implementation, your build will fail. So we set a number of places we expect, we allow for people to not use the component implementation. And if someone adds another usage, this fails the build and suggests that they, well, I won't say it suggests they use the component because it really requires them to, but they can increment the number of exceptions if they need to. So as we roll out a new component, we just decrease that number of exceptions, and that prevents new ones from being introduced. We also use this analytics code to generate a basic report on our progress. So this is actually stats from our code base right now. You can see that we've migrated every blank slate to use the view component. There's like 400, actually there's 490 of them. So now whenever someone goes to build a blank slate, they always use the component 100% of the time. Take a little break. Does anyone have any questions?
I have one. Hopefully it's quick. How do you track the numbers on the graphs of the view components, like the number of view components over time?
How did I do that?
Yeah.
So for this, I can send you the code later if you ping me to remind me. There's a git command you can run that you can give it a timestamp, and it will give you the first commit, like I think it's right after that timestamp. Mm-hmm. And then you check out that commit and then run whatever command you want to run. Like in the slides, if these slides are all marked down and they're on a branch on my website, on my repo, and it has the code that we use to run all those stats.
Cool. I figured it was something like that. I just was curious.
Yeah.
So I have a question for you, Joel. I don't know if you want to wait till the end.
No, that's fine.
So one piece I'm struggling with on this is I could see why this would be applicable to a very extensive legacy code base, but I'm having a very hard time seeing why I would ever start to use this at a new company when I could use all their JavaScript tools natively from the jump.
I mean, it depends on how much you want to do client-side rendering. We tend to have a pretty strong aversion to client-side rendering at GitHub, so it's almost like a philosophical thing.
I think it's more than philosophical. I mean, there's speed too. So I mean, you get away with it because you have $1 billion budget to throw at caching, but arguably speaking, I think that I guess what I'm trying to say is, like, would you say that this is the best case for both a legacy project, which is what this is being applied to, and a new project, or is it just more? That's kind of where I'm riding in the fine fence, because.
Oh yeah, that makes sense. Yeah, so I think that the first answer I would say is that this definitely is the most powerful when you have reusable UI. So like if you're working at a company that has a design system, which is a lot of companies these days, like that is a common trend in UI design, is that you will use a system. So like, I mean, someone has started to build view components for Bootstrap. That would be one example. Like if you have these reusable patterns you're doing over and over again, that's that's really helpful. If you're starting out like a small greenfield Rails application, probably not a great idea. From a speed perspective, I'm going to be honest with you, Chris. We've had mixed results with our experimentations, we do some experimentation with React. We have actually not really shipped any React. We're trying to. We're not finding that in the end, with our level of complexity, that it's faster for the end user than doing server-side rendering. So I guess my answer would be like, it depends. If you're really happy writing front-end code in JavaScript, this is probably not the tool for you because it's not in JavaScript. There's definitely a section of the Rails community that thinks that there is still that server rendered views are still very viable. I think that I would point to the recent release of Hotwire as a very strong signal in that direction. If the company that created Rails is continuing to double down on server-side rendering, I think that's a sign that like there is at least some belief in the community that that is going to be a viable approach for the long term.
I also feel like I read a link. I also feel like I read a link adjacent to to Hotwire specifically that was showing browser render speeds, like a performance render, that the CSS HTML engine inside browsers is faster than the JavaScript engine. So if you're serving it server side, that the actual experienced render time for the consumer is better than if you hand them a pile of JavaScript and have the browser run the JavaScript to render the DOM.
I think that kind of touches on why the way I think I would ultimately explain the way we think about the equation, the performance equation, which is that on a great computer, an SPA is a fantastic experience. It's very fast, it's very zippy because you have all this local compute that you can throw at the problem. The problem is that not everyone is using a great computer. Some people are using, out of date JavaScript engines, or they're on a, if you even just look at Android JavaScript performance on Android versus iPhone, the difference is remarkable. So if you're ever building, that's an aside, if you're ever building a JavaScript application, always make sure you're testing it on an Android phone because it's going to be remarkably slower. So if you think about it, like we could have an uneven front end experience in terms of performance based on our clients' hardware characteristics, or we could do that work for the customer on our servers, maybe at a slightly slower end result for them. But that end result is going to be very consistent regardless of the characteristics of the client. And that is kind of like our overall approach. It's like a progressive enhancement approach that we firmly believe that we should be doing the work and not our customers when it comes to computing UI.
Well, but even that, a lot of that's being done and being brokered and pre-built rendered to S3 on Akamai, and that's insanely fast because you're not even hitting the web server. So you could pre-gen and run all the JSON and throw it up there, so the SPA doesn't have to do it. It could just rip it in. So like you don't have to do all of those pieces. So there's Shopify is doing pieces out where they're blending it. To that question about the browser piece, I do think it's highly tailored, but I guess I'm a little skeptical. I'm very skeptical of the one single company, not to name mention, that backs the one product that also took years to get to Webpack 3, when Webpack 3 arguably with the pre and post processors was one of the most revolutionary items on the front end. And DHH just refused to do it because he's DHH.
Yeah, and I think that like, and that's actually something I'm going to touch on and here in a couple minutes, but like, it's tricky because the other thing I would say is that like Rails provide like a lot of the reasons that we're all here, at a Ruby meetup, still writing Rails code is convention, and convention is what allows us to have our sponsors at the beginning of the meetup tonight that said, we'll hire you if you're a Rails developer. Because Rails is built on these conventions that are so universal that it allows you to move from company to company with I think the most ease anywhere in this industry. And I think that what I'm cautious about when it comes to front end technologies is that there isn't a ton of consensus and convention. Especially, just in the JavaScript community in general, there's just a million ways of doing things. And as a Rails developer, I tend to prefer things that are conventional and well-established and closer to the Rails way, because the closer, in my experience, the closer you are to the Rails way, the more likely you are to not have to do some sort of massive rewrite down the road, because there's some sort of like conceptual alignment of everything you're doing. And this is getting like really hand wavy. I don't know if that's a great answer, Chris, but like, I'm really cautious of deviating from Rails, because Rails is so opinionated that often you end up fighting those opinions. Like you're exactly right. Like if you want to use like a new version of Webpacker and it's not the Rails way to do it, it's gonna be a little painful.
I mean, I appreciate your candor. I want to say that. Like, I struggle with this too. I think that I'm really big on convention as well, but I've kind of made that little line in the sand when it comes to the view layer, right past the JSON. Like when you're actually rendering the styles or rendering all those, that's kind of where I've kind of bled. And I saw that entering the community in the last 2-3 years, especially with the Webpack, you know, I won't get into that whole like battle that happened a lot to get that in. And Webpack was actually what sold me on the separation, was the pre and post processors. When I started using those, I was like, wow, like I could write what code once and I don't have to deal with it, which was the convention on the front end side finally to some extent. But I do agree that a lot of the front end projects are very different on every company, like very, very different.
And I think that like if you're asking for like, you know, the question here is like, would you use this on a new project? I mean, to be honest with you, I would use neither this nor React. I would write a vanilla Rails app, and I think that is maybe where like I would see this kind of trend of server rendered UI coming from ultimately, is like a really pushing back against what I don't want to like flame bait, but I would call it unnecessary complexity that is being introduced to a lot of applications. So you can think of ViewComponent as a more incremental approach to get some of these, you know, nice UI abstractions without completely throwing away your front end. Does that? I think I'm gonna leave that there, because
it does. It's good. Yeah. Thank you. I also do want to say that the testing of this is awesome, though. So
yeah,
like,
and
awesome.
To be fair, like I didn't say it explicitly in this talk, but like most of these ideas are ripped straight from React. Like even the name, like slots, that is actually what it's called in the JavaScript ecosystem, and we very purposely use the same name. This is basically challenging the project conceptually challenges the assumption that you need to throw out everything that's Rails convention for front end to get X, Y, and Z benefits. Because I would argue that you can get a lot of those benefits through an approach like ViewComponent, or, you know, other things you can do without, you know, rewriting your front end in a different language. Anyways, I'm going to continue. So by a lot of measures, this project has been very successful in the open source space too. We've been lucky to have a lot of engagement on the project. We've had code contributions from over 80 developers, and only a dozen of them have been employees of GitHub. And it's been really, it's been interesting. You know, working with a lot of people from all around the world has been a really big lesson in empathy for me. What stuck out to me is that, you know, on a repo, we get a lot of issues, PRs, and discussion posts from people. You know, sometimes English isn't their first language, or they're new developers, or they're coming, say, from a different background. And, you know, there's something really, really special about getting all these different perspectives. And it's really made me think about how there is always something to be learned when someone tries to contribute to a project, you know, even the small stuff. So like, you know, the other day, someone was confused by the documentation and they ended up writing a component incorrectly. Well, that made them feel kind of bad, and they were like, oh, I couldn't figure this out. And I was like, well, did you read the docs? And they're like, yeah. And I'm like, well, maybe the docs aren't very good. Like, maybe we should improve the docs. And we went and improved the docs. Or like, you know, if someone gets an error message and they come to the library and they file an issue and says, you know, I got this error message. I'm like, well, we should probably improve the error message if you had to come here to ask us about it. And, you know, looking at, you know, seeing all these people come together on this project has made me realize that a lot of people in the community really want to contribute to open source, but they're not always sure how. And what that's really made us think about managing this project is, you know, how can we make it easy for people to contribute? You know, we want to enable people to make high quality contributions as easily as possible. And the library isn't super complicated. Like the test suite runs in like 2 seconds. Like it's not a ton of code, but it has some nuance, and it has to behave slightly differently depending on the version of Rails that you're using. And we support several combinations of different versions of Ruby and Rails. I think it's like 2.3 plus and 5.0 plus for Ruby and for Rails. And making sure that every change works for all those combinations is really critical. And one way we've reduced the burden of this is through matrix builds. So this is a way you can use GitHub Actions to run your test suite over different combinations of Ruby and Rails. So we do this to ensure that every change works across all of these combinations. And that's an expectation that you would never have on any engineer. Be like, oh, did you bundle install Rails 5.2 and then switch your Ruby version to 2.6.6 and then run the suite? No, we're not going to expect people to do that. But perhaps more importantly, this has enabled us to ensure we have 100% test coverage. So by combining coverage data from all of those matrix builds, we can have a confident foundation that makes it easier to accept contributions from the public. And we do this with artifacts. I wanted to show, this is a little tricky, but you can use the upload artifact GitHub action to look at a folder and upload it and actually rename the folder. So this first step, it looks at the coverage folder and it uploads it with this special naming. And then we have a dependent build called coverage, and this waits for all the test matrix builds to run. And then it downloads all of the artifacts and runs a rake task to combine them, to combine the coverage reports. And this is actually something that's built into SimpleCov. It's just called SimpleCov collate. You give it a blob that matches all the coverage JSON files, and we configure that with 100% coverage requirement. And that means that if someone opens a PR, I no longer have to say, well, can you please write some tests? Because it will fail the build if it doesn't have test coverage. So with all this infrastructure in place, it's a lot easier to accept PRs that have passing tests, because we can be really quite confident that they aren't going to break an existing API. Another lesson we've learned on this project is just how powerful Rails convention is, to speak to the conversation we just had before this section. When writing this library, we aimed as much as possible to align it conceptually with existing Rails conventions. And what that's meant is that those Rails conventions have translated into baseline expectations for our code. And those conventions have enabled others to almost instinctively know how to contribute to the library. So for example, someone in the community, Juan Manuel, contributed almost pretty soon after we open sourced the project. He wrote ViewComponent previews. And these were largely based on the convention established by Action Mailer previews. He was actually able to copy some of the code out of Rails and modify it to work with ViewComponents. Any questions? Okay. So what?
I have 7 comments and questions at the end whenever we're ready.
Yeah.
But they're quick.
Anyways, so I think it's also worth talking about what hasn't been working well with this, to kind of get at Chris's probing from a couple minutes ago. There's really one fundamental problem with this approach that I can't shake, and I think it's best embodied with one of my favorite XKCD cartoons of all time. Basically saying that, often people propose solutions to technical problems as some form of introducing a new way of doing something, and that just creates more ways of doing something. And what ViewComponents means is that in a Rails app, you now have 2 different ways of writing views that work differently. Like ViewComponents behave differently than traditional Rails templates. And because of that, I really can't imagine this getting into Rails in its current form, at least as they exist in a separate directory. Like today, you put your components in app components, and then your views still exist in app views. But that makes me think about what could it look like to start to extract some of these lessons into Rails. One example of this, 2 folks in the community, Andrew Culver and Dom Christie, wrote a gem called Nice Partials. And Nice Partials provides a similar API to slots. And it allows for multiple blocks of content to be passed to a partial. And maybe this is something we could add to Rails. So I think what we ultimately need to focus on in the long term is improving Action View. So from our work on ViewComponent, we've identified a couple ways Action View could be improved. And as the ViewComponent API continues to mature, we'll have an increasingly clear idea of what those improvements might look like. And by doing so, I think it's really important that we'll be able to design whatever the future of Action View looks like from experience and not from hypothesis. One example of this is the lack of robust support for some of the existing caching APIs in the ViewComponent library. We don't do a lot of we don't do a lot of like view level caching at GitHub at all. So it's really difficult for us to build the framework support for it. And that's a good example of like where we really actually need help on the ViewComponent framework, because it'd be really hard for us to build that feature correctly because we don't have experience in that area ourselves. So the last thing this project has really made me think about is just more generally innovation in Rails in 2021. So there's a book called The Innovator's Dilemma. It's widely considered to be one of the most influential business books ever written. And it basically says that the innovator's dilemma is the decision between catering to current needs or adopting new innovations and technologies that will answer future needs. And really what the book demonstrates is how successful, outstanding organizations can do everything right and still lose their market leadership, or even fail completely as companies, as new competitors or ideas come in and take over their market. And I think this is an important lesson we need to consider about the long-term relevance of Rails. And the reason this matters so much to me is that GitHub has a huge dependency on Rails. Like GitHub's future is pretty dependent on Rails remaining relevant. And because we have so much code built on top of it, and it's very unlikely that we'd rewrite a lot of that into something else. So what does that mean for all of us? Like, it means that we need to innovate. We need to experiment with new and potentially disruptive ideas like ViewComponent, because improving Rails is the only way we will survive. And it's going to take work. We need to take ownership of keeping Rails relevant for the long term. We need to be good citizens. We need to participate in the project. Rails was built people just like all of you, and we benefit from the work other people have put in. But we need more voices. Like, we are the people working in Rails today. And what we really need are more extractors. We're all, as Rails developers, a lot of us have worked on multiple applications. We know what the underlying pain points are. We know what we know what gems we add every time we build an app. And ultimately, if you think about it, like, the survival of our companies depends on it, because picking a framework is forever. Rewrites are rare. But yet somehow the world moves on. And I think it's important to remember that it's ultimately up to us to keep Rails relevant. Thank you.
Nice work, Joel.
Gosh, that was so long. Oh my gosh. I'm so
What
sorry.
day is this?
I practiced it. It was 40 minutes. You guys asked so many questions. Like, how does a 40-minute talk
There were no
become...
questions. There were no questions.
Is there time for more?
Blame it on us.
All right, Joel, I want to point. I'm going to go through my quick list in 2 minutes. 1 minute. Joel, your slides say 2020. I'm sorry. Just want to tell you that.
Damn it.
Yeah.
You can tell what year I wrote this
the
in.
whole thing. Record the whole thing. Let's see what else I got. No idea you're in the Zysis team. I just not play later. I'm a tough needle. The Rails app there is from 2012. I think you thought it was old. I'm apparently wrong, right? I used to write mailers in 2006. Just want to say that. What's your editor color scheme, by the way? It's very muted and not glossy. I'm curious about that. It's hard to read in actually slides, by the way, for everybody else. I assume agrees, but what color scheme is that?
It's a custom theme our designers made for deck set. Yeah.
I assume.
Does anyone have useful questions?
How popular is the dark mode that your team implemented? I know you know this. Do you want to talk about it?
I know exactly how popular it is, and I don't know if I'm allowed to say.
But very popular.
I will say that a significant portion of GitHub users have at least tried it. Yeah. It's very popular, though. I mean, oh my gosh, when we first announced that feature, I had built in like the real-time analytics for people interacting with it, and it was like on fire. Like thousands of requests per minute just around the feature. Yeah.
Final question, because no one can ask questions about that, is no question. I just want to mention, as you know, Next.js, very interesting. We used it, e-commerce use case, React server-side rendering, as you know, very useful, works well. End of message.
Let me know when you have a convention that like people from two different people can agree on.
Oh,
Next is the convention. React is the thing.
It is. It is. Why do you think it is? Why do you think we're copying React?
Correct.
That's exactly why.
Thank you.
All right. Go Ryan Cook.
I'm curious, Joel, if it's reasonable to compare slots to content for in Action View.
It is. Yeah. There's some performance concerns with Action View, and actually, honestly, I totally missed the boat on demoing the real power of slots because they can actually be defined as classes and they can take arguments themselves. They can also be lambdas. So you can actually have like effectively a subcomponent inside another component. And that's actually how we use them in practice. I was wary of explaining that level of technical detail in them because it gets pretty gnarly. But almost all of our slots actually take parameters. Like you might have like, a header that has a variant. Like this is something Bootstrap does. You might have like a card and the header gets like a danger variant and it has like a red color and whatnot. Yeah.
A different question is there any world you see where the view models and the view components coexist, or do you feel like it's like a total replacement?
It's a total replacement. Specifically because of testing. Like I actually think that that's the thing that it's really uncovered is we've gone in and we've found view models that have methods that are never used, and we've gone in and actually audited like the result of the view model and it's not been used properly. So like the testing gap is really real. There's like a kind of a blank space. Like you write a view model and it's like, I feel really great because I wrote unit tests for a plain old Ruby object and they're fast and they're done and I TDD'd it, right? Well, like no one cares because that object is never actually interacted with directly. It's an indirect artifact that goes into your template. So I view this, and I think that is actually a good way to explain it. I think that ViewComponent in its current state, I would call it a first class, like Rails, a conceptually compatible Rails expression of the view model pattern. In like, I think one of the more robust forms.
Thanks.
So I have one more question for you, Joel, not related to the React one, related to email templates. Curious, why, I'm guessing this might be a scale thing at GitHub's size, is that you're doing the templates inside and shipping them versus using like a broker API, something like SendGrid or, where you basically just fire it and they manage all the internal templates. You don't actually have to code them.
Source control is why. If you knew the things at GitHub that were under source control, it would blow your mind. We've had everything is a repo at GitHub. Like for a long time, I'm pretty sure who was employed at the company was a repo. I know that every single permission I have at the company in terms of like access to any resource is actually expressed in a Git repo. And if I want a new resource, I open a pull request, like access to a new resource. I open a pull request and it maps into an LDAP group. If that gives you an idea of the way we think about third parties. We also, I know from under the hood, we use different email providers for different regions. We obviously have to interchange with them because we would never have a dependency just on SendGrid, for example. We have to have 2 email providers.
I do agree with you that the email templates are total pain in the ass.
They're total pain.
Total nightmare. Yeah.
Yeah, and there are libraries that handle it. They're just like really heavy-handed. Like I actually wouldn't be surprised. I'm hoping we can get the mailer ones to a point where they're open sourceable and just add those to the design system because they're really great.
Thank you, man. Thanks.
Yeah.
Would you do a quick reminder of how or if we can use these?
Yes.
I forget.
So the library is, like, as you saw with those matrix builds, it's compatible with Rails all the way back to 5.0. It does so with a monkey patch, and that monkey patch is very performant. We actually used that monkey patch at GitHub for a while before Rails got the patch that it landed in 6.1. 6.1 includes a patch that basically is just like a few lines of code that allow you to pass an object to the render methods, and those there's a hook that goes into the framework. It's not super interesting. The monkey patch can conflict with Wicked PDF, I think. So there's actually a way you can turn it off, and then you just call render component in your views, and then it just works like in basically any version of Rails.
do another hour, like one more hour, you think? Just like.
I got more slides. No, just kidding.
Keep it rolling. That's great. Any more questions, thoughts, appreciation?
It's
Great-
fun to
great
see the
job.
update. It's fun to see the update. Like saw it in 2019, and it's fun to see it now. And like, nice work.
Thanks.
Agreed. Great job, Joel.
This is the longest I've ever paid attention to anything in my career. I've worked on this project longer than I've been employed at any other company in my entire career.
So you've invented a solution for ADD?
I've done that
Doesn't have it.
once in my life where I like worked on a project for a lot of years and did totally different size and scope of project, but doesn't it like just change how you think about like software? Like, I mean, I'm used to consulting where you kind of drop in, you do the thing and you're done and everything's a blank slate, or you're dealing with existing stuff, but it's not your stuff. But here, you're probably seeing your own problems, right? You're like,
Dan, that takes 2 weeks for me. It doesn't take 3 years. No, I think that what it's made me really think about is actually not necessarily seeing my own problems, but thinking upstream. So like, there's actually 2 ways I think about it. One is like, what is the root source of like a defect I'm working on? Often for me, it's like, okay, there was no designer in the room when like a page got built. That's a common one. So like, part of my work is actually fixing the process that led to this problem. Because if you don't, I mean, we write all these linters, right? But even then, those linters aren't going to totally solve the problem of undesigned, like non-system designed UI in the application. Like that has to be solved further upstream. The other one that you could send me on a 45-minute rant on is how what you saw today in terms of the problems I talked about, I view as a direct consequence of a glaring deficiency in the Agile manifesto, which is that the Agile does not have, at least in the way most people use Agile at most companies, have a sustainable, it's not what I would call a 100% sustainable system. It has what in economics would be called a negative externality, and that negative externality is technical debt. In that if you do Agile properly, you will have technical debt. Because if you're just sprinting and incrementally hitting MVPs over and over and over again for a decade, you're never going to like have a refactor cycle where you find all those abstractions and actually simplify them. And that is actually ultimately the innovator's dilemma. That book, I just skimmed over it briefly. The innovator's dilemma is a very general version of that exact problem, which is that generally as companies get bigger, they accrue this overhead on innovation. And as they do that, their competitors come in who don't have that overhead and they just destroy them.
I have a slight nit to pick with what you just said, Joel. I got to say, I totally agree with you. But my nit to pick is I actually think when it was earlier than that. I think extreme programming had some stuff. And when it got switched to Agile to be able to sell to enterprise bought fast computing, not Agile computing. And we have been mistaking speed for agility for decades. And the agility is the ability to change direction. And
correct.
Corporations are not interested in changing direction. Corporations are interested in predicting what happens next quarter and hitting that mark.
Exactly. That, I mean, that if you ask Sandy Metz, like the Rubyist, what her number one criteria for software quality is, it's changeability.
Exactly.
Who cares? You can throw any other metric at the wall. How it looks like to change your code is in her mind and in my mind, the only way to judge like overall technical quality.
Yeah. Really nice.
Again, great work, Joel. The time and effort you put into your talks is impressive.
So now that I can stop recording, I can tell